lie to me, okay, that there is a presentation in this course, and you should get a topic to me, about a half-page abstract on what you want to discuss. Just for your edification, Kristen has already decided to talk about virtual memory and its relationship with operating systems. Okay, so you can pick a paper, you can pick a topic that relates to operating systems.
So I can do like,
Sure, you can do you can talk about threading, the threaded model. You can talk about scheduling out. I don't care. So anyway, when is that due? When's the abstract due?
Friday after midterm.
Friday, yes. No later
it's not
than.
that we do it together, right?
You can't do it together.
Okay.
No later than the Friday after the midterm. Okay, good. And questions if there are any. Okay, so most of you may have heard of Maya Angelou. She's probably the most prolific 20th century American poet, civil rights activist, hung around with Martin Luther King and them during the civil rights movement. Okay, Christian, she's just a neat person.
Did you hung around with?
Yes, she did. She was a contemporary. She was a contemporary of Martin Luther King. Okay, good. So, moving on then, talk about the simple shell. We briefly started to discuss this last time. I want to go through it again. I'm going to have you code this thing up. Okay, there it is. That's what you're going to code up. So, I mean, you don't necessarily have to understand it in detail since I've handed you the code, but it would be nice if you understood what it is that you're coding. Okay? So you can see what it does. What does a shell basically do?
Interpret command.
It waits for a command, accepts the command, and what does it do? It forks itself, and then execs the command. All right? It forks itself and execs the command. So let's take a look at how this works. So line 9 through 14 are the object-oriented program. They're called objects. Real people call them variables. So these are the variables. So we've got mostly arrays. We've got command, which is what the user enters at the command line into this shell. Then it turns out that what we're going to do later with the thing that they enter is we're going to break it up into its pieces. We're going to parse it. Okay? There's going to be the command itself, whatever they issued, and then up to 2 different arguments called argv1 and argv2. All right? And then this auxiliary variable called search is going to allow us to find the spaces that are between. So typically you would go what? Like, as an example, you would go cp space file1 space file2. Right? That would be one line. And how would I know where the pieces of it are? By looking for the spaces. Okay? So the token that delimits, in this instance, the line, is a space. So that thing called space, that thing called search, is the token that delimits the pieces of the command. All right, so in the example that I've given, cp space file1 space file2, what's the command itself? CP for copy, right?
Right.
And what's the first argument?
File1.
File1, what's the second argument?
File2.
And you see that they're separated by spaces.
Right, right.
All right, good. That's the ID. And then CPID is going to be the process ID associated with the child. That thing which gets forked and then ultimately execed. All right, good. Now, infinite loop on line 16, while true. Okay, in other words, forever. So, if you're running this thing in the Unix prompt, how do you kill it off? In Unix, Control C.
Control C, okay.
Control C in Unix. So that's how you kill off the Unix process most of the time. Control C. Okay? Put out the $sign prompt on line 18. In line 19 comes from standard I/O library. It's called file get string. File get string, or fgets. Okay? Has 3 arguments. The first is the buffer into which the response is placed. The second argument is the maximum number of characters that it will read. And the third is the file itself, the stream. Now, what's this STDN business? That's called standard in. Anytime a piece of C code runs, there are 3 file streams that are already open. And it turns out that they go to devices. How can a file stream go to a device? Because what kind of files are these devices?
Directory?
No.
They're identified.
No.
Special files.
Ah, yes. See, there was only 3 choices.
Yeah,
So eventually you had to get it right because they're special files.
Yeah.
And so look at this. I'm doing input with a file command. File get string. fgets. And again, the first argument is the buffer into which the result goes. The second argument is the maximum number of characters to be read. And the third is the stream or file. In this case, already open, called standard in. Any speculation as to where standard in is in the absence of any other insight? Where would you think standard into a computer would be? Where would the standard input come from?
The keyboard.
Keyboard.
A keyboard, yes. So line 19 sits there after line 18 spits out a dollar space, then the computer sits there, waiting for the user to go, enter. And as soon as they hit the enter, whatever they entered, the fgets grabs it, places it into the string called command, including the carriage return at the end. So fgets keeps the new line that's at the end. All right, now, here's what we do. We then, notice command of strlen of command. So what does strlen do? Somebody speculate what strlen does. String length. That's how many characters are actually in command. Not how big is the buffer, but how many characters are there. All right? So notice what it does. It says, take command of however many there are minus 1. Because what's the last character in that buffer? What's the last character in that buffer? Remember I told you, you go enter. So what's the last character that's in the buffer? It's the new line character, which we don't want. So this, the combination of lines 19 to 20 are considered a safe alternative to the function gets. There's a function gets. And if you compile a piece of C code with gets, a decent compiler will tell you that it's dangerous. And the reason is, if I enter something into gets that exceeds the buffer length, C doesn't care. It'll just walk off the end of the array. And what's that called? When the buffer overflows, what's it called? A
Stack overflow.
Buffer overflow. Okay? And a buffer overflow is one of the vectors by which exploits can be implemented. What you do is you arrange your code so that your array that you read into is right near the end of your space. Okay? Then you do a gets, and it overwrites the buffer, but what the characters that go in there are executable code. Then you vector your code to that function. Bam, suddenly you're into the computer. So buffer overflow is one of the vectors. So gets is considered unsafe. Lines 19 and 20 eliminate that. It's a safe alternative to gets. Now, the next 3 lines essentially parse that command line. If it were more than 2, I would have done it in a loop. But since there were only 2 of them, I don't. So here's the way it works. I'm using the C library call entitled stratoke. And what it does is it parses a string based on a token, okay, and brings back the pieces that are delimited by that token. What did we say the token was in our case? The space. So the first time I say, do a stratoke on command with search. And what that will do is it will give me everything up to the first space.
Okay.
Then subsequent calls, it gives me the next piece of the line where search occurs. And the third time it gives me the third piece of the line. So what if there were 12 things delimited by a space? Then I would do the first one, command get stratoke of command comma search, and subsequent commands, notice what command is. It's null. So then I just go in a loop, I equal 1 to 12. Bam, bam, bam,
Okay.
and we find them and parse it up. Boom, 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 looking for the space.
So parsing is, it takes the space.
Breaking it up into pieces,
Okay. Okay.
right? And by the way, the token that you're looking for doesn't have to be the same. I could look for space, comma. So if I had fields that were numbered, 1, 2, 3, 4, 5, right? Then I could use as my token the numbers 1, 2, 3, 4, 5, and be able to locate them. So that's stratoke. It's a fairly useful C function. Now, what does this do? This is a very common thing to do in C. Notice that, by the way, this extra set of parentheses around the CPID gets fork. Okay? In an arithmetic expression, what do parentheses do?
They multiply?
So, I mean, what if I had 3 plus 2 times 5? What would the answer be?
Yeah, well, they prioritize the...
They prioritize. In other words, the stuff inside the parentheses happens first.
Right.
Okay? And so in C, you do the same thing. So CPID gets fork, does two things. It forks the process and assigns to CPID the process ID of that child. Now here's another interesting thing about C. In C, the statement itself has a value. It seems goofy, but if I said to you, let me erase some of this. I don't know who this professor was in the last class. The guy's one of the students.
Say it again.
What a nightmare.
Say it again.
Somebody needs to slap that while I'm telling you. So if I said, what's the value of, if I said to you, what's the value of 3, what would the value of 3 be?
What's the value of 3?
So if I said, what's the value of 3? What's the value of 3?
3.
This 3, dirt, right? What if I did this? What if I said A equals 3?
A's value is 3.
So A's value is 3, but so is the value of that expression.
Right.
That entire expression is equal to 3.
Okay.
That's why in C, you will sometimes see stuff like this. A equals B equals C equals D equals 0. Why does that work? Because it starts on the right and it assigns to D the value 0. Now, what's the value of D equals 0?
0.
0. That gets assigned to C.
C.
Now, what's the value of C equals 0?
0.
0.
0.
That gets assigned. That's why that works.
Okay.
So statements themselves have a value. So when I up here say CPID gets fork, that entire parenthetical expression has the value of the child's process ID. Not only does CPID have the value of the child's process ID, but that entire statement. Then what do I do with that?
If it's
I
less
say
than
if
0.
it's less than 0. Now, here's the deal. If it's less than 0, that means the process could not be spawned. Translation, the fork failed.
Okay.
Okay? So if the fork fails, then this piece takes over. And what do? We say, sorry,
Exit.
can't
Print.
create child, I'm leaving, and then we use exit CPID. That'll show us the error code.
Yes.
So when fork fails, it returns an error code. And we in turn send that out to the command line so that the user would know why it failed. Now, most of the time this won't happen, in which case it'll just not do the body of the if clause, but it will still have forked the child. All right? You need to get used to this type of programming, because we do this all the time. We'll do some things like, if file pointer equals f open, blah, 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 and then the error code. Then we go to the next line. So if it didn't error, that means that it must open the file, and that file pointer has the right value. So it's a really unusual way of programming if you used to Fortran or these other languages. So moving on then. So now, and I've copiously commented, and I did send you this as a PDF. Well, some of you refused to acknowledge that I did.
Sorry, on my phone.
But I did.
Thank you. Wow.
Okay. So now, if CPID is 0, what does that mean?
Is the
child process ID is 0.
That means that it's the child.
It's a child. Yeah.
Because remember, the parent has associated with that variable CPID some greater than 0 value.
Right.
Some process ID for Unix. Okay, 3,742. But the child's instance is different. So remember, we've got two identical versions of this code running. The parent's version CPID is greater than 0. The child's version CPID is identically 0. That's one of the characteristics of fork. Okay, fork, if you fork, then the child that gets forked gets, for the CPID value, 0. All right?
And that's always the case?
Yes. If you assign to a variable equals fork, then that particular variable in the parent will have a greater than 0, and in the child will be identically 0. Okay, it's the only time, it's one of the few times that C initializes variables. Okay, and it's a result of the fork command. So just before it starts the child process running, one of the things that it does is it takes that variable that was used in the fork process and gives it the value 0. And the reason is so we know if we're the parent or the child. Okay, so if we're the child, then what do? Now, here we go. Without too much understanding, we're going to use the one version of the exec command. There are multiple versions. The version that we're using works this way. Command, you can do a man on it. On the Unix command line, you say man exec LP, and it'll tell you why those variables work. Okay. For now, I won't explain it and say the principal piece is command argv argv2. Command argv1 argv2. The exec command, remember what does it do? It replaces the current image with the new image.
With a new image.
And in this case, gives it the optional command line arguments, argv1 and argv2. So if there was a piece of code that implemented CP, and there is, because I could at the command line, I can go CP space file 1 space file 2. This shell would grab that and it would exec itself, and it would exec the command called CP, and it would send to CP argv1 and argv2. All right, good. Then finally, otherwise, so as soon as it execs itself, what happens to this code that you're looking at? As soon as exec works, what happens to the existing code that you're looking at? It vaporizes. It's not there anymore.
Yes.
It's a critical point because it looks like no matter what, you're going to get exec fail, doesn't it? It looks like no matter what, as soon as the exec gets done, it appears that, I'm going to get error, exec failure, and exit 1. Doesn't it look like that? But the reason that doesn't happen is because as soon as exec occurs, this instance of the code vaporizes and is replaced by whatever you exect.
Okay.
It's a critical deal, okay? Now, if exec failed, then the existing image wouldn't have vaporized,
Right.
in which case the pairer and subsequent exit makes sense.
Yes.
All right? Now, if it's not the child, what do? Else, it must be the parent.
The parent.
You just do await. And what wait does in this usage, wait with the argument null, it sits there and waits for child processes to terminate. And as soon as the child process terminates, then it goes back up to the top of the loop, puts out the $sign prompt, grabs the next command. So it's an infinite loop, grabs the command, execs it. As soon as it's done, it comes back, goes back up to the loop, grabs another one. Okay. So that's the simple shell. Now, a real shell does all kinds of other cool stuff. Okay, does all kinds of other cool stuff. So this is a rudimentary shell. So then moving on. I want to talk about some, what I call, watered down Unix commands. So there's an English colloquialism called watered down. Okay, like if I talk about watered down soup, that means you take, because you get too many visitors, so you take the soup and you put more water in it. Okay, so that's literally where it comes from, watered down. And we use it as a colloquialism to mean something that's not as strong as it should be. It's not the complete thing. So if I said, give me a watered down example of something, that would mean, show me a simple example. So I use that terminology here, watered down Unix commands.
Okay.
So I'm going to show you a series of real Unix commands that are simplified. And they're so simplified we can actually write the code to do them. Okay, we can actually write the code to do them. So here we go. First of all, I want to talk briefly about C's macro capability. In particular, if you don't learn a whole lot about programming, learn the first bullet, to parenthesize the macro and each of the parameters. And the example is shown here. Now, look at on line 6 of the top left window there. Clearly, what's the intention of that macro?
To multiply the two variables.
To multiply A times B. That's the intention, isn't it? Mul, A comma B means A times B.
Yes.
But what the compiler does with macros is it engages in what's called textual substitution. It's copy-paste. So every time it sees mul AB, it replaces A in the thing on the right with whatever the A is. And so now look, if I were to say I gets mul of 5 plus 3 comma 5 minus 3, what do I think that I'm doing? What I think I'm doing is I'm multiplying 5 times 2. Sorry, 8 times 2. Isn't that what it looks, isn't that my intent? Right? 5 plus 3 is 8 times 5 minus 3, which is 2. It looks like I'm trying to get 8 times 2, and it should be 16. But instead it comes out as 17 as shown to the right. And the answer is clear, because what it does is shown in the comment to the right. It prints it as 5 plus 3 star 5 minus 3. It takes the A and puts it where the A is in the macro, and it takes the B and puts the B where the B is in the macro.
Okay.
It's pure textual substitution. So the rule is to parenthesize. So here's an example. This looks really nasty, but this macro called isLine of C, okay, tells you whether or not we're at the end of a line. Okay, now how do we know what characters denote the end of a line? Well, a new line character. Okay, how about a form D? Okay, how about a carriage return? And how about a vertical tab? Now look at that ridiculous looking thing. So you parenthesize all of the arguments, and you parenthesize the macro itself. Okay, so in the previous one, in the upper left, what would have been the correct way to write that?
To parenthesize both of the.
I would have said parentheses, parens A, parens,
Right.
times parens B, parens, parens. That way you're safe.
Could you repeat that, Dr. Moore?
Sure, I'll show it. So, before if I had a working pen, the second time.
How is equals to? How is it equal to 17? It's not.
So if the macro was # define mol of A comma B as A star B, and I subsequently use mol 3 plus 2 comma 5 minus 1, then what that translates to is, which one of these is the A?
3.
3?
3 plus 2.
Yeah.
So we go, okay, A, that's 3 plus 2. Then star, and what's the B?
5 minus 1.
5 minus 1. Well, sorry, but 3 plus 2 times 5 minus 1 is not always the same as 3 plus 2 times 5 minus 1. So
Right.
here's how you insulate it. You would go, so this would be wrong. And in its place you would go parens A star parens B parens.
Yes.
And if you just adopt the habit of always doing this with every macro, you will never get into trouble.
So Dr. Morris, could we, instead of changing it there in the macro, could we change there in the mode?
Sure, but then you put it on the end user to do it right. So don't rely. There's a saying: those who try to idiot-proof code fail to understand how. How's it go? Something like you underestimate how stupid people really are. Okay? So, and by the way, it's not just regular old macro. It's not just function macros. Watch. Let me erase this. Remember, all macros in C are textual substitution. So suppose I want to say # define x as n minus 5. Suppose I want to do that. All right? Now, somewhere later I go, okay, so then y gets, x times 17. Now, what do I think that I'm doing?
You think you're multiplying?
I think I'm taking n minus 5 times 17.
Right.
But that's not what's happening. What's happening is, x, n minus 5, textual substitution, n minus 5 times 17. Okay? And n minus 5 times 17 is not the same as n minus 5 times 17. So the solution is to put parens around the macro.
Yeah.
So you put parens around the macro, the full macro, and if it's a function macro, you put parens around the individual arguments.
Okay.
All right. So that's out of Isaiah for C programming.
And how do we simply define macros? Is this a substitution
It's
system?
it's an easier, because if I had some very complicated thing like this, I don't have to put this every time I'm checking to see if it's a line. I just go, is line C, and I'm done, bam. Right, so macros are a shorthand way of expressing a repetitive type of scenario.
Yeah.
Okay? Good. So, macros. So there's by the way, there's your isLine macro. You'll need that later. So here we go. So here are some Unix commands. Echo. What does echo do? It echoes its arguments to the standard out. What's standard out normally? The screen, sure. Then touch. Here's what touch does. Touch either changes a file's timestamp, or if the file doesn't exist, it creates an empty new file.